Okay, oxidation number. Oxidation number is very important with the redox reaction. Now, you have to know that the oxidation number is different from the real charge. Let's look at here. First, all the elemental state, like for example, sodium, iron, copper, all these elemental states, the oxidation number for it is zero. We have seven diatomic molecules, O2, N2, Cl2, I2, F2, and Br2, and H2. For all of these, oxidation number it is zero. Now, for the element, when it will be, before that, the ion will equal the charge in a positive one, so it will be positive one oxidation number. Cl negative one, so it will be oxidation number equal to negative one. Oxygen 2 negative will be 2 negative oxidation number. Now, when the element will be in a compound, we have some rule to follow it. And sometimes we need to calculate the oxidation number for the element. First of all, group 1, like sodium, lithium, potassium, when it will be in a compound, will have a positive 1 charge. Group 2, metal, like calcium, magnesium, barium, when it will be in a compound, will have 2 positive charge. Aluminum, 3 positive charge. And the halogen, group 7, which is Cl, iodide, Br, chlorine, when it will be in a compound, will be negative 1. Hydrogen will equal 1 positive. Okay. By the way, we have some exception for hydrogen or halogen or the oxygen. Oxygen usually 2 negative. As I said, we have some exception, but don't worry about the exception right now. Just focus in these kind of data so we can use it to calculate the oxidation number for the other element. We need to know the total oxidation number for all the elements in molecule or in a compound will equal the charge. What does that mean? If it's a neutral compound like NaCl, the total should equal 0. If I have SO4 2 negative ion, the total will equal 2 negative. If I have CO3 2 negative, the total will equal 2 negative. If I have K2 Cl2 or 7, get a neutral compound, so the total will equal 0. Okay, let's practice with some example to find the oxidation number for some element. In a compound. And as I said, this is very important, the oxidation number, to decide which chemical will oxidize, which one will be reduced whenever we have oxidation reduction reaction. So let's go with H2, sorry. Let's go with H2 and so forth. And we need to find the oxidation number for sulfur. We know hydrogen, 1 positive for each hydrogen. oxygen for each oxygen, 2 negative. What about the sulfur? What's going to be? Okay. The total of the oxidation number in this compound will be equal to 0 because it's a neutral, nothing there, 0 charge. So here, what is the charge we have? 2 times 1 positive for the hydrogen plus S, or you can assume X, whatever it is, plus 4 times 2 negative for oxygen, and that will equal what? Equal 0. Solve the problem mathematically. S will equal here 6 positive. Look, when we have a negative, a charge ion, like Cr2 or 7, 2 negative, we need to find the oxidation number for Cr2. So here we can assume Cr is X because we have Cr2, so it will be 2X plus 7 times 2 negative for each oxygen will equal what? Will equal the charge, will equal 2 negative. Solve the problem mathematically to find the X. So here 2X will equal 12 positive. Each X will equal 12 positive divided by 2, and that will give you 6 positive. So the oxidation number for Cr here, 6 positive. That's how you're gonna find the oxidation number for each element. Sometimes they just give you, for example, oxidation number of H2. Here will be 0, it's elemental state of hydrogen. I have just iron, 0. I have ion, Fe2 positive, will be 2 positive because it will equal the charge of the monatomic ion.